And hi, welcome to week 10. Any questions on anything before we start going? Things been going well so far? I think so. Okay, and there will be a test on the last day, just kidding. That would not be fun. I hate doing tests. I really hate doing tests. Especially when programming is a much better way to test you on things. So what we're going to talk about today is taking code generation. Why does that not look right? And connecting it with manually written code. There's a bunch of different techniques for this, some of which are utter crap, some of which are painful, some of which are very easy. But depending on what you do, there's a lot of convention that you might have to follow in some cases. There's a lot of APIs you may have to follow in some cases. Sometimes there's limitations as far as how much communication. All depends on which approach you take. Obviously, the most flexible thing is if you wrote all the code by hand, right? I mean, if I went in and wrote my whole GUI by hand, I can put hooks in wherever I want to do whatever I want. But as soon as you start doing code generation, you're doing some trade-offs. You're trading off some consistency, some error checking, and getting rid of some of the boilerplate and tedium for the control that you're going to have on it. So you have to try to figure out, how am I going to interface between my code and that generated code? One of the most common early ways that people did this was that they would say, here is my DSL. I'm going to generate code. Wow, that's this pen not working here. And then, at that point, I'm going to sever ties with my DSL. So I'm going to use my DSL for a single time generation. And this is a valid approach, but it can be quite painful. We tend to see some of this in kind of a mix and match approach. Xtext does a mix and match of single time generation and every time generation. So when you initially generate with your grammar, it gives you a bunch of shell classes that you can then from there take and modify. So actually I should have probably just started up my Eclipse here so I could show you what I'm talking about here. But when we create a brand new Xtext project, and no matter how long I stretch that sentence out, it's still going to take longer for Eclipse to start now, isn't it? And no matter how long Eclipse takes to start, it's still shorter than an Android Studio build. So I'm going to come in here and it's going to prove me wrong, isn't it? I don't know what this initializing plugin model is. I threw a few new plugins into Eclipse that I was playing with, so this might be, I'm paying the price for that. And now it's building the workspace. There we go. So let's start off by saying I'm going to create a brand new project. And it's going to be an Xtext project. foo1, how about that? And this will be foo1 dot foo1 DSL, and this will be foo1. And I'm not actually going to do anything interesting with this. And it's going to show you what ends up being generated here. So we have our little grammar. If we take a look, to start with, there's nothing under source gen, nothing under extend gen, and under source, there's only two files in here. Let me just make sure that I got that running again. Good. When we do our first generation on this, so I'm going to come in here and right click on my MWE and say run as MWE2 workflow. Watch what happens to my source directory. So we'll notice that there's a lot of skeleton code that got generated for me here. It started off by giving me a shell of a generator, a shell of a scope provider, and a shell of a validator. That's really useful. Underneath source gen and extend gen, these are things that are generated every time I regenerate my grammar. So we're using a combination of single time generation and every time generation. This allows you to take advantage of some stuff that is nice from a top level so you don't have to write it by hand. Like we take a look at our foo DSL generator, it gives us a nice skeleton here because remembering what to do here or having to look up what to do here might be a little annoying every time you do it. It also sets up this standalone setup and this runtime module. This runtime module here is where you can plug in your code that you want to be used to inject into your IDE. They use a dependency injection framework called Juice to do, that's Google's dependency injection framework, to hook in features. And if we take a look at this abstract foo1 DSL runtime module, we'll see that this one's completely generated, he's down underneath source gen, has a whole bunch of default bindings. So for configuring the scope provider, he says scope provider is set up this way. And by generating this little shell class for us, we can override that if we want to. I'm going to come back to this in a minute. This particular pattern between these two files is called generation gap. What we've done is we're generating a superclass and allowing the user to edit a subclass. We generate that subclass once to give them a starting point. It's just a convenience. And then the name of this foo1 DSL runtime module can be included in other generated classes. So basically what we've done is created generation class, created a subclass that we can now modify by hand, and that subclass is reference places automatically. We're going to come back to that again and other times. So we see there's a nice combination of what it's doing on our generated code, giving us kind of a little handhold to stick our fingers in. Oh, why did you turn off? Don't turn off on me. There we go. So this single time generation was a real early on approach at DSLs, or just code generation in general, saying, hey, plug in some things, I'll give you a skeleton. This is very, very common in things like new project wizards, where you might not really think of it as a DSL type situation. It's really just a code generation where you're taking a template and saying, give me something to start with. And I'll plug in a few little values. You can kind of think of that as a graphical DSL, the wizard that you enter in those few values. It tailors a template and gives you those new project wizards. But it doesn't keep generating that code every single time, or it doesn't generate that code after that initial step. Does that make sense? Okay. So this is a very common technique. Sometimes you use it as your complete generation, like in the new project wizards. Sometimes you use it in combination with other types of code generation. Okay, questions on that so far? Okay. So it's very, very useful. Now, sometimes you have code that's generated every single time you run. Very common. You modify your model, you update the code automatically. This is where we get in trouble when we start trying to communicate with our code. Now, if this guy here is completely standalone, and this is very common if you're generating a model. Like let's say I wanted to generate a data class that just has a bunch of fields and a bunch of getters and setters. Maybe has support for Java Bean bound properties, VTOLable properties, things like that. We can generate that code and just use it wholesale and not worry about mucking around with it. Other times there's types of code where we really want to get our fingers into it, like the GUI builder that you guys built. It'd be really useful to be able to put hooks in there to do things with those buttons, to do things with the data that you're getting out of there. Maybe write it to a database, maybe populate the fields, things like that. If it's all standalone, this is pretty straightforward, pretty easy, right? We can just use the generated code wholesale and not worry about it. Now, obviously, if some of the classes inside here change, like if I go to my DSL and I remove a class, boom, the class is going to be removed in my generated code, which is going to have impacts on my use of it. But sometimes, oh, something just disconnected. I don't know what it is, but let me just make sure Camtasia is still running okay here. Yeah. I just heard the little sound of disconnecting a USB device So I'm not sure what it did, and my mouse is working. This guy is working. Yep, I think we're good there. Never mind. So using stuff standalone, we don't have to worry about it, right? But then when we want to start getting our fingers in it, that's when things get tricky. Now, the real early approach people took here was something called protected regions. And what we would do is we would go in, and in that generated code, have something that might look kind of like this. So maybe what we see out here and there is code that is just pure generated code and is always generated every single time. And then it throws a little comment in there for you automatically. This block here is one where if you put your own custom code between that begin 001 and end 001, so I could come in here and write some custom code right in there, then the next time we're generated, what will end up happening? Well, what do you think is going to end up happening the next time we generate? Pretty much. Let's think about the process just a little bit more cleanly there, though. So when we take our generated code, he's going to generate the code, and he has to do something with those protected regions. So if we think about a previous generation, so the last time you generated, you have code that's been previously generated. If you have a protected region set up, then your DSL processor is going to have to generate a new code base independent of the existing code and then merge them. Normally with code generation, you're just going to say, boom, overwrite what I had before. It's an easy operation. But as soon as you get into protected regions, you now have to always have two copies going. The previous generation and the current generation that you're modifying. Then you can run some kind of a merge tool there to merge those regions together. There's one called JMerge, for example, that'll do things like that. Taking these two sets of generated code, looking for those protected regions, and merging them together. Okay. Then you end up with the new source. You get rid of your old source. And then this becomes your previous generation for the next build that you're running through. Make sense? This has some interesting properties to it. So if we think about this for a minute, we have a whole bunch of code. And then we have some more code here. Come on, be consistent on the things I'm using here. And we have more code there. Now think about how this is going to work from time to time. Maybe to start with, up in here, we have a text field that you're generating. And I'll call it text field A. And maybe down here, I have text field B. Maybe down here, I have text field C. Now think about what this code's doing for a minute here. What happens if I remove text field B? If I'm no longer using it? So it could break the custom code in the O2 part. Let me put one more little block in here. There we go. That's the big danger. If I remove this guy in here, depending on how smart my code generator is, this guy could become 002. Which would mean that the code that I had at this point would now come after text field C. That's not good. So if you're doing protected regions, got to have some good smarts in your code generator. This one just won't work. And this is the initial stab that people usually take at protected regions, is they will have these things just be numbered. Oh, this is my first protected region. This is my second protected region, blah, blah, blah. So what do you think we might want to do here? Instead of having 001, 002, 003. So we have to keep track of which things belong to which component. So that means that every component is going to have some kind of ID to start with. And then, so if we look at the code that we're generating for a specific component, we might have a, wow, why is that doing that? Component A pre end component A pre, and then maybe the setup component A, and then maybe have a begin component A post, and then end component A post. And maybe this is, a typical block for how we set up a given component in our GUI. Think about all these protected blocks we have all over our code now. There's a ton of protected blocks in there. That can be a little sticky. And let's think about source control for a minute. When you generate code, it can generate a buttload of code for you, right? What happens if you check that into your version control system? You're going to inflate your repository. What else?
Every time you regenerate it, could trigger a change. It might not even be a real change. It might just be like the time tag.
Every time you regenerate, it could generate new deltas in your source control repository, which could cause merge conflicts, even if there's no real content change. I mean, the thing that you pointed out are timestamps. It's very common to see in generated code, generated at X from file Y. And sometimes, if file Y didn't have any real meaningful change to it, some of your generated files might not really have changed other than that timestamp. That's going to cause unnecessary differences in your version control system and potentially more merges to go in. So the general approach for dealing with source control is do not check in generated source. And that's a really, really common best practice. Yes?
Does that also relate to if you're delivering the generated to a project to use? Like if it is a deliverable to another project, obviously you want it. Right?
Okay. Yeah, so if it's a deliverable to another project, then you want the artifact to contain the compiled generated code. But typically you're not going to include the source. And you're going to want to set it up so that your build scripts will generate the source, then generate the artifact, and then install the artifact in whatever repository, or deliver it, or put it on a file system, or put it on a server somewhere for people to access.
So the boundary would be the actual library or
So yeah, what you're going to hand over would really be your end artifact, your jar, your war, something like that, or if you have other languages, your DLL or shared library, whatever you end up having to distribute to people. So in general, avoid checking in the generated code because of stuff like this. Now, depending on your system, now that the system that I was working on with a couple tools, I have this thing where I have 2 copies of Eclipse running where I'm editing the DSL, and then I'm using that DSL to generate code, and then that generates code into another project. Typically what I did for a lot of those is so that other people didn't have to deal with the Eclipse stuff going on in there. I would check in the code that got generated from Eclipse so that people could use it as a library. So it's essentially going to be a library situation. And ideally, that would have been a jar that I hand off to them. But a lot of times when I first started this process, I'd go ahead and check in that generated code, which can cause merge conflicts. But because I was the only one who was doing the code generation, so whenever people needed a model change, I would make the model change, run through all that mess, and check it in. There wouldn't be any conflicts on it. If you had multiple people doing that generation, you have conflicts like crazy. And it's a real nightmare, especially with the timestamps. And timestamps can be really useful in generated code. As is, if you have generated code, put a comment at the top that says warning. This code was learn to spell, Scott. You thought my typing was bad. Was generated from DSL file xyz.foo. Put a comment in there, big at the top of the file, and quite possibly at the beginning of every method that you generate. Because if you don't do that, what's going to happen? If somebody just does a control click to follow into a file, they're going to jump into a method, and you're really going to want to have some warning there saying, don't touch this. Now, this is one place where Eclipse really just crazily outshines IntelliJ. What Eclipse does is it has this indicator of a file being derived. So that if you go through a build process through any of the Eclipse builders, you can set that derived flag on a file, which is kept with the Eclipse project. And if somebody starts to try to edit it, it's going to pop up a little dialog saying, hey, this is generated code. Do you really want to mess with it? Let's see if it'll show you that in here.
That's actually how I tested my generation for the moment. Because it's been so long since I wrote Java. I would generate what worked, and then I would add what I wanted to be like, hey, you're changing your code.
Mm-hmm. Yeah, this it looks like this file is not marked as derived. I'm not sure why they didn't have that marking as derived there. But when I did some work on the Antler code generators, I went in and set it up so they were all marked derived, and then also set it up so that it had the source mapping files set up so that when you debug, you could actually step through the grammar. That was a joy. It was cool. It was a cool thing to do, but yeah, it was a little bit painful. So here's that derived flag here. If it got set through the plugin, which it should be, and I'm not sure why they're not doing it, then if I let's try that one more time. Derived, apply and close. Let's see if it's going to do it now. There we go. So it'll say this file is derived. Do you really want to edit it? And this is one of those warnings that you should never disable. This is a really great way of saying you're in the wrong spot. I can't tell you how many times in IntelliJ, like when I'm Android Studio in particular, when I'm walking through and debugging and then making tweaks as I debug, that I've actually gone in and I've been editing code that's in the bin directory or the build directory. And I don't notice it up front until I'm editing it for a while. I'm like, why am I not getting all the right code assist here? It's things just aren't getting I'm not getting the right pop-ups. And then when I build and rerun, the change just doesn't seem to be there. It's because it just got overwritten. And IntelliJ gave me no warning about that whatsoever. A lot of times you'll see this little bar at the top that says there's alternate source available. And that's because it's picking up source in as a generated file in the build directory. It's like, thank you, IntelliJ, for being completely useless. That reminded me of How to Train Your Dragon. There was like some line where he says, thank you, you useless creature, or something like that. Awesome film. Has everybody seen How to Train Your Dragon?
So, I watched it with two of my friends who had decided, it was like the night of the MLB All-Star, Home Run Derby or something, so they were playing a drinking game for that. After that was over, they decided to drink every time they say dragon.
Oh, God. Really?
They don't actually say dragon that many times. You see a lot of dragons, but they don't say dragon.
Right, because they also say the type of dragon more than they say the word.
That's true. That's true.
It turned out to be not very anticlimactic.
I watched it with my 2-year-old, and he just was like, dragons, and then he went to play with us.
And then he took a drink, right? Yeah, it's like, actually, if you want a good drinking game, you pop up the Teletubbies, and anytime they go, uh-oh, then, yeah, you get toasted so fast. Um, but yeah, how to train, I mean, I'm nervous about How to Train Your Dragon 3, because 1 and 2 were just really good. And for DreamWorks, that never happens. I mean, DreamWorks is usually, they have one really good one, and then, Shrek. The first one was good. The rest of them, ugh. But How to Train Your Dragon, it's like, I'm looking forward to the third one, but I'm like, please be good. Anyway, I don't know how I got off on that tangent. Because of what that sounded like. So anyway, put a warning in there. And the more places you can put that warning comment, the better. It's in generated code. It's not going to matter. I mean, it's something that, if you put it at the beginning of every method, yeah, it's going to inflate the size of the file, but they're comments. It's not going to hurt. It's going to help a user if they accidentally go in there and start editing it. And I usually put a comment in there saying, warning, editing this file is known to the state of California to kill baby seals or something like that. Because everything is known to the state of California to be bad for some reason. It all causes cancer. Everything in the state of California. Okay, so we got a new page there. Let's pop him up. And we'll come back over to here. Okay, so yeah, showing you the generated code there. Let's see, what was there's something else on that page I was talking about before I popped off of it. So yeah, don't check in your generated source code in general. That said, how do we do that if we're using protected blocks? If you're using protected blocks, you have, and if you edit the protected blocks, you have to check that code in. So this is where some people, when they were doing the protected blocks, would start splitting out their code into 2 directories. If they ever had to modify something, they would put an indicator in the DSL to say, this is a file that I'm actually going to tweak. And so they would dump that into one source generated directory that they would check in, and anything that wasn't flagged as tweaked, they would generate into another one, which is completely blown away every time. So they get kind of a mix of, I'm only checking in the stuff I really need to check in. It's like, ew. So then people started thinking of other approaches to this. Well, why don't I have a step in my build process that takes my generated code and extracts the code blocks that I've tweaked into a different file that I check in. And then what I do as part of my build process is take that checked in file, stick its code back into the generated code, rerun the generator. The build then takes that and checks that stuff in as a separate file. Think about that for a minute, though. What am I doing there? We have code that's inside here in a block. We're extracting it to somewhere else, checking that in. We now have
without each other.
well, that's most of a program anyway. So we now have, here is our generated code. And then we have these little chunks over here that we're basically pulling out of the generated code and keeping somewhere else. And then sticking it back in place. Any idea what this looks like? If someone were to just draw this picture for you and say code, 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 without knowing about that whole build process mess of extracting the stuff out, checking it in, and then squeezing it back in, what might somebody say we're doing here? Possibly, but that's assuming they know the build process. If I just drew this diagram and I said, okay, I have this generated code, and some of the code is sitting out here, some of the code is sitting out here, some of the code is sitting out here. Function calls. Kind of looks like separate function calls, right? And why not? Why not think of it that way? Instead of actually having code that you maintain in line, why not pull it out? Instead of having those protected blocks, if I set it up so that each of those protected blocks is a function call in an interface, or let's say an abstract class. Let's say that we had, here's my generated code, and we have call x1, call x2, call x3, call x4. And then we generate one time an abstract class that has call x1, call x2, call x3, call x4 as empty. And then you can override those. Problem, of course, if I generate that one time, what happens when I change my DSL? It won't capture any additional things, right? If I rename something, if I remove something, if I add something, they won't show up over in this guy. So now what do I do? Let's draw this out again. Here we have DSL. Here's my generated code. And this is going to be an every time generation. And he's going to have call x1. Let me just say x1. And then the generated code x2, generated code x3. And these are calls to this guy here where I define x1 as being empty, define x2 as being empty, define x3 as being empty. What if I did this as an every time generation instead of being generated once? What can I do now if I want to tweak something? Let's say I wanted to actually do something in X2. How do I do it? Subclass. So I can come over here and create a subclass that extends this guy, and this guy's an abstract class. And over here, I just override X2. And boom, now I have my concrete class there that's going to have my little helpers. Now how do I get these helpers into that generated code over there so I can actually call it? Dependency injection is one way of thinking about it. We're going to inject this object into here so that we can call each of these methods. We can generalize the concept of dependency injection there and call it a strategy. Strategy pattern is a real generic pattern. It's basically, instead of me doing stuff for myself, I'm going to call out to somebody else and have him do it for me. So dependency injection is an approach we can use to get that strategy object in there. But we now have a nice strategy approach here where we have two every time generated things and then a concrete guy over here that we can plug the data in. Okay, that's a possible approach there. Or, what's another approach here? Let's take a look at this in a slightly different style. What if our generated code went ahead and defined those guys and then somewhere inside here calls x1, x2, and x3. And then we just subclass the thing that was generated to start with. We skip out that middleman. This has a very different feel to it now. So now what we're doing is the generated guy is the superclass as opposed to the generated strategy piece being the superclass. And both of these work perfectly fine. This is the more common generation gap pattern, where what we're doing is generating that superclass for us, and then we maintain the concrete guy who fills in the blanks. And if we look at the filling in the blanks in both of these approaches, so we have this guy here, and if we go back over to this one, we're still filling in the blanks in both cases, right? In this approach, we're plugging in the thing that's going to do the help for us, versus in this approach, we're subclassing to do those helper things for us. Make sense so far? Both of these are using the code up inside here. And again, anyone know what it's called? What pattern? Template method. And the template method pattern, the way I always like to describe it, is a algorithm with replaceable steps. So we're going to do something, but at certain spots we want to do something different. We want to let somebody else plug in differences. And there's two ways you can plug in those differences. Subclass to override them, or use a strategy to plug them in. Template method and strategy go hand in hand for this really, really well. Where here is our template method, and then the strategy gets plugged in instead of overriding the methods in a subclass. Now, what's going to be the big advantages, disadvantages of these two different approaches? So if we thought about the more traditional template method here, which is just where the base class has the hooks in it that we want to override, and then we make a subclass to fill in those details. What might be some advantages to this approach over the other one? There are fewer moving parts, right? That's a big advantage. You know, when you look at this, there's one less layer to think about. And that can be an advantage, right? It's a little bit simpler to conceptualize. I'm just going to subclass this sucker. Okay? And that's a benefit. Okay? What's a drawback here?
If you change the ordinary code's functions, then your concrete's going to also change.
Okay, so if you change the generated code's functions, the concrete guy is going to have to make some changes. He's going to break. You're going to get that same type of effect though in the strategy approach, because you're going to have the same set of functions that you have to deal with. So not really a plus or minus for either of these two.
You can't, well, depending on the language, your concrete one can't subclass something else.
So depending on the language, your concrete one cannot subclass something else. And that's a huge problem here. When we look at Java and look at Kotlin, you can have a single superclass. Now, it's getting a little bit nicer in Java and Kotlin where you can actually have concrete implementations of methods in interfaces. They can't access member data, but if you just want to have helper methods, you can carry them along an interface, and that works just fine. So you can have mix-ins. As well as doing some kind of delegation. Becomes very, very useful there. But commonly, the big problem here is you're required to use your superclass. And that's the big disadvantage to the template method pattern, the classic template method pattern, is that some languages you're kind of screwed. Your superclass is done at that point. If we look over here at the template method and strategy combination, here it depends on what this guy is in the middle. If it's an abstract class, you have the exact same problem, right? If you make that an interface, not an issue at all. You can now have other superclasses. At what expense? You have to implement every method. So there's a trade-off there, right? Okay. And that might not be too bad. Let's think about that have to implement every method thing. Some languages have some really cool features in them. Something doesn't feel right here. That's weird. It actually inserted a...
Kotlin that implemented with
Yep, the by. So there's some languages that have auto delegation. And you can do this in, I believe C# supports this, Kotlin supports this. I'm more familiar with Kotlin. Kotlin took a lot of great cues from C#. I mean, I think they did a brilliant job with Kotlin. I really wish they would have fixed the syntax and not have it be C syntax quite as much as they did, but it's a step in the right direction. But the idea of auto delegation is what you can do is, let's say we have an interface. Let's say I'll say iFoo, and he has X, Y, and Z required. You can then have a null implementation for him. And when I say null implementation here, I'm talking about the null object pattern. One of the advantages to the null object pattern is that instead of saying, I have to check to see, do I have that strategy impl by saying, is it null, is it null, is it null, is it null? I can just plug in an object that just says, don't do anything in all those methods. And then I can just call them without having to check if it's null or not. So we can define a null implementation of it to start with. And then in our actual implementation, we say class A implements iFoo by null impl, paren paren. And what that does for me is generate, first of all, an instance of null impl, and then for every method inside iFoo, a method that delegates to it. So the code inside here would look like X ends up calling, I'll pretend this was called ni.x. Y calls ni.y. And Z calls ni.z. So it generates that for you. I walked right into that. I didn't even realize it was going to come. Not planned. Sometimes that happens. So by doing that delegation, this creates a true mix-in for us, where we can treat it kind of like a superclass. We're going to implement all those methods, but handing it off to somebody else to do the work for me. And if I explicitly said, here's a definition for X, it skips that one. It actually wouldn't generate that ni delegator. It just goes ahead and has our implementation. So it lets you override the ones that you care about while pulling in the garbage. So I can use my DSL to generate both of those guys for me. And then that gives me some support so that when I'm doing my coding over there, I have this dummy implementation to start with. I mean, think about, one sec, think about with Antler when it generated that parser listener. If it generated one of these null parser listeners for you, and you were using a language that allowed interface delegation, this would be fantastic, wouldn't it, right? Now, I think I mentioned that Java Bean annotation stuff I did a while back. For Java, I implemented a thing in there where I had interface delegation, so that you had an annotation saying, I'm going to you implement this interface using an instance of some class, and it would generate all these delegate things in a superclass for you. So your superclass, we're using generation gap pattern there. The superclass would have all the dummy delegators, and then in your subclass, you could override wherever you wanted to. Yeah, question.
So we're talking about generating these methods when you compile the code, not like in code you can see, but in compile.
So generating which methods are you talking about?
The like Y and Z, for example.
So like these here, on this side, these guys?
No, so in Kotlin, right, if I have class A, if I have that,
Oh, it's over
Y
here.
and Z don't actually appear in the code.
Right, Y and Z would not appear in your source code. So these guys here get generated automatically for me behind the scenes. So basically when the Kotlin code gets generated down to Java code or Java bytecode, depending on how you have it set up, those would get generated for you automatically. So those are ones that you would normally have had to fill in with dummy implementations. You get them for free. And it just delegates for you.
So that's called extend
This is called shoot. What was the exact term for it? I like to call it auto delegation in general, but I think the actual term for this is just interface delegation.
I've never heard of it.
Yeah, it's a very very nice feature. Let me see if I can.
It really looks nice. It's just, it's not at sea for sure.
Oh no! Oh no!
It's where I've been living, so
Yeah. So if you just look up interface delegation with Kotlin, um, yeah. So we have like make that a little bit bigger. So you have something kind of like this where you can say class derived B base, and you can explicitly put an instance here or have an instance being passed in. I'm pretty sure.
base
And you can still use this B instance other places. If you didn't need to use the B instance anywhere else, you could just directly just say base paren paren.
because then it would make its own instance.
Mm-hmm. Actually, no. You'd have to say base impl over here, because base is an interface. So you could, instead of having the parameter here, you could just say base by base impl paren paren, and that would work fine. So depending on if you wanted to pass in the thing to delegate to, you could do it this way, or you could just directly have the implementation of it. So
And that's how you guys get around, or that's how you just get around only being able to inherit from one.
yeah, this is one very very strong way to get around single inheritance. This is a very typical mix-in approach where you're pulling in, you're basically delegating to other people. Delegation, most of the time, I want to prefer delegation over inheritance. Inheritance has a specific meaning to it. There's that is a relationship, and you really want to strive for only having a superclass if it makes sense that you can be used everywhere that superclass is used. If you're pulling in a superclass just to get his helper methods, you're abusing OO. And it's really not a good way to do things. Doing a delegation to somebody else is really the way to use somebody else's functionality, so you get your reuse, without giving that extra definition of I am an instance of this guy. One of the things that ends up happening is that a lot of times, do you know what Liskov substitutability is? The idea that anywhere my superclass is used, I should be able to be used. Think about one of my absolute favorite horrors in Java.
You can do delegation in any language, right?
Oh yeah,
Do it
yeah.
explicitly.
You would just have a whole bunch of these delegate methods. And in Eclipse, they have a nice feature for, yeah, if I do something kind of like, let's say an interface, funky, and I'll have void foo, void fee, and then if I have a class stuff, and I'll say colon funky. Oh, wow. Okay, then what I can do here, let's see, will this work on this one here? Well, this will add on implemented methods, but what I can do inside the class is say generate delegate methods. Oh, I need a field for it first. So we'll say funky a equals new funky impl, which I didn't define, did I? New class funky impl funky, and so there he has whatever methods he's going to do there. And so then inside here I can say generate delegate methods delegating to A, and it generates those for me. So this is basically what Kotlin's doing behind the scenes when you use that by, is it will generate this type of garbage behind the scenes. It's noise, but it's very, very useful noise, because now I can take advantage of the support that funky impl has without saying I'm a funky impl. Because what I'm really, when you implement an interface, you're not giving it an is a relationship. You're saying here's what I say I'm going to do for you. It's a contract. And implementing that contract doesn't necessarily imply an is a relationship. So using delegation is a much better way to say, I just want to use his functionality. I don't want to be him. Because being him wouldn't necessarily make sense. Okay, make some sense? Okay, so one of my favorite pet peeves is Java util list. And this is something that they screwed up royally when they did Java 1.2. Kotlin's list does things right. The problem with Java util list is he defines a get method. It sounds reasonable, right? A size method. But then he had to go and define an add method. This is telling you, if you have a list, you can add to it. That's the contract, right? And this says that anytime somebody needs a list, he should be able to add something to it. So if I have a foo over here that says, give me a list, I require a list. By the contract, he should be allowed to say list.add x. They didn't give any type of way to have an immutable list here. So what they did in Java, being absolutely brilliant on this, they created a subtype of this guy. Well, no, actually they didn't. It gets worse than that. List is an interface. They created a wrapper called immutable list that will take a base list inside of it, and he implements list. I don't have room to write out implements, so I'm just going to say colon. And inside here, his get n delegates to base get n. His size delegates to base dot size. And what does his add method do? This is utter evil. I mean, just complete evil. This breaks the concept of what's known as Liskov substitutability. And I'm not even going to bother to try spelling that right now. I'm just going to scribble it out. Barbara Liskov came up with this concept, basically saying anywhere that I need a superclass, I should be able to use the subclass equally as effectively. This is a complete breaking of Liskov substitutability. And it's a simple concept. It basically says, if I say that I'm a foo, I can be used anywhere a foo can be used. This is where it breaks down. Because they have implementations of list that don't adhere to that contract. This specific thing here is known as a refused bequest. The idea being a bequest is something you inherit. And here we're saying, nope, I refuse that. I'm not going to do that. And anytime you have a refused bequest, you're breaking Liskov substitutability, which means that common libraries that do things like this will break down if you try to pass them somebody who says, I'm a list, and he really isn't. Now in Kotlin you have list and mutable list, which is how they should have done it in Java. But they screwed it up royally back in 1.2. And they were trying, I mean, the main reason they were trying to do this is they were trying to say, I want vector to be able to implement list. And vector already had an add method in it, because they didn't have a concept of an immutable vector at that point. So we're stuck with it. And this is one of those things where early on, they didn't want people to use vector anyway. They should have just done this right. Yeah. And yeah, I mean, it's just, I mean, vector's synchronized, so it's slower. Unfortunately, with list, you have the wonderful concurrent modification exception, which, it's useful to catch stuff like that. I'm walking it and modifying it at the same time. But, there are times, if you have a linked list, who cares if you're modifying it while you're walking? It doesn't hurt anything. If you have an array list and you're checking to see what's my array bounds, then yeah, we're going to have problems. But in a lot of cases, who really cares if you added stuff to it? Sometimes when you're doing a walk through it, you might want, let's say you have a linked stack. Maybe you're pushing new things on the end as you're walking, or they should be more of a queue, right? You're adding things to, you're queuing things as you're processing to, increase your processing workflow. That might be perfectly valid.
I don't think anyone uses linked lists in Java though.
No, not really. I mean, well, it depends on there is a linked list class
I know.
that'll do it for you. It just depends.
Even at the times you think it helps, it doesn't really.
It's pretty rare. Yeah, unless you're, the only time that it's really useful is if you're going to be doing, modify stuff in the middle operations a lot. Why, especially while you're trying to walk it. But it's almost useless. But yeah, breaking list call substitutability, a really, really bad idea. And it's a really good concept to know.
You never find out about those stupid exceptions until runtime.
Yep, which is huge. I mean, exceptions like this for the refused bequest, yeah, you won't hear about it until runtime. And it's especially bad if you're using a third-party library and you throw a list at it. And, they may not be prepared to handle that. They may be saying, you're telling me it's a list. I expect to add to be there. Any idea what pattern this is called? That is known as a decorator.
But isn't it like the opposite of a decorator?
But isn't it the opposite of decorator? Technically what a decorator does, technically what a decorator is, it's a wrapper using the exact same interface. So I can use him anywhere I can use the original base object. I've wrapped it to tweak the functionality. Whether I'm tweaking the parameters going in or whether I'm tweaking the return values coming out or tweaking some kind of behavior, which is what I'm doing here. This is a very unfortunate tweak of behavior because it breaks the contract, but it's a decorator. An adapter is similar. It's a raptor. It's a wrapper, but it's a different interface that's coming out of it. So you're basically using it to wrap something and expose the guts as a different interface. Adapters are very useful if you have, let's say I had a list like this and I wanted to present it in a J tree for whatever reason in Swing. JTree has a specific interface for how do I determine what nodes I have in the tree. List has a specific interface for saying what data do I have in my list. Wrapping that with an adapter that exposes it as a tree model will now allow me to just drop it into a tree because I'm reinterpreting the data using a different interface. So these two are very, very similar. The key difference is, am I using the same interface? So are they basically, can I use them interchangeably? Or am I using it to change to a different interface than its adapter? Make sense?
Yeah, I've always thought of the decorator as adding stuff.
It's really, you still always have the same methods at least. So you can always add more things to it.
Yeah, but the true pattern is if you don't add anything, you just cover what's there with whatever you want to do before you do what's there.
Adding things to it really doesn't hurt because it's still compatible with it. And sometimes there's cases where you're decorating it to analyze behavior or track extra behavior. They're great for things like creating a test wrapper around things so you can actually see what got called. And then you can have a couple extra methods to say, let me find out what got called. And then inside it just keeps that, tabulates it along the way. In general, you usually don't need to do that, but it doesn't hurt. As long as it's the interface that you're implementing and the final thing is compatible with the original interface, then it's a decorator. Okay, questions on any of that? So, yeah, Java util list is evil. Okay, let me pop the stack a few times here and figure out where I was. So this is what we were talking about before, right? We had our subclass. We were talking about doing delegation, using a template method here. So the difference is here by directly using the generated code as my superclass. The drawback is I'm required to use my superclass. By using that little guy in the middle and taking a strategy approach, I can now use auto delegation and not have my superclass taken up. Or just directly delegate it myself. I could just implement all those methods and then I don't have to have my superclass taken up. And that's actually really useful. And in thinking about this, maybe it doesn't make sense that this guy is that guy, whatever that guy is. Maybe I'm really just plugging in a few little helper things. And I don't want to be considered that superclass. So in general, I like to prefer strategy or delegation over inheritance. Okay, make sense so far? So some very, very useful ways of dealing with your generated code here. Now let's see. So I have my strategy with the base generated, strategy generated. We can specialize this just a little bit more for certain type of situations. So if we have here's my generated code. Let's say this generated code is going to be creating a user interface. Sound familiar? You've done that before, right? The generated code might have some hooks in here. Is this one what I want to have this one go with? Yeah, actually I do. So let's say my DSL says I've got a frame that contains a button and contains a text view and so on, something like that. And I generate some code there. What if I had a create button method, a create text view method, create frame method, and the code that's generated calls those helper methods, uses them to create the elements, weaves them together however they need to be weaved together, and then I use a strategy here with those three create methods inside there to fill in the how do I create a button, how do I create a text view, how do I create a frame. What have I created here? I mean, this is a strategy still, right? But a little bit more specifically, it's a factory. And taking it a step further, we can call it an abstract factory. Well, let me call this here the abstract factory. And this is a concrete factory that I'm passing in to actually specify how do I create a button, how do I create a text view, how do I create a whatever that other thing was that I wrote on there, a frame. When might this be useful? Abstracting away platform specifics. So maybe I could have a concrete factory for Windows. Maybe I could have another one for the Mac. Maybe I have another one for Android. I don't know how easy it would be to make a similar thing work for all three platforms. It might not be that easy. But we can abstract that information away. And now we've got the concept of how do we wire our interface together from how do we actually implement it at the metal. So down at the actual, when you're on a platform, what happens there? When you have a situation like this, using an abstract factory like that, it's often called a bridge. The bridge pattern basically takes that into account where you can say, I've got some code here, I'm going to delegate out to abstract away platform specifics. If you're not abstracting away platform specifics, you're probably not doing a bridge concept. One of the things with the Gang of Four patterns is there's a lot of them that the code is exactly the same. All that changes is your intent. And that's a huge key. And again, with design patterns, that's always my big push is communication of intent is what design patterns are all about. But as you can see, a lot of these Gang of Four design patterns and other design patterns really fit with code generation very, very nicely. And I like calling out what the patterns are explicitly, just so you can kind of see how the terminology fits into code generation here. So this could be a really nice, giving you one more level of abstraction if you need it for something like this. I'm not going to make you do this in your assignment, by the way. I don't see a whole lot of point to that. Okay, everybody's got to go out and buy a Mac or buy Windows if you don't have the other one, and then do it both ways, and just for one assignment. Yeah, that would be worthwhile, huh? Okay, does that make some sense? So sometimes a factory can be useful to abstract out to do things like that. Okay, so we got our delegation. Now let's talk about something that I want you to do in your assignment. I've got some base code. And this is code where I'm going to create my user interface, for example. So let's think about what that code might look like. Whether we have protected blocks, whether we have strategy, whatever. The general gist of this is I'm going to create a frame, create buttons, create labels and text views or text fields. And maybe, whether it's in a subclass or a strategy, I want to be able to access those and do something with them. So I want to say, hey, text field, put this data in there. Hey, text field, when you have data, give it to me so I can store it in a database. Maybe I'm creating a button. What do I do when the button's clicked? Let's think about that for a moment. How can I handle a button click? What different approaches could I take to deal with the button click? Thinking about what you have in your code right now. We're defining a button, right? We're not dealing with the clicks. How could we implement what to do on that click? Let's think about some different approaches. Okay, so if it's an internal DSL, we could directly use a lambda or an anonymous interclass or some kind of an action to say, here's what to do. Internal DSLs really win on that, right? Because you're inside a host language, you can do whatever you want in that host language. That's huge. It makes things so much easier. Okay. Now for an external DSL, things get a little trickier, right? So what can we do in an external DSL? If we want to respond to a button.
You can add a listener that just calls some abstract method that either strategize or whatever you're going to do with it.
So what I kind of did something like this, where I did in order to get the validation, I did an interface that had the abstract in there, and I defined the lambda and put that in a map, and then I just called it the map. So that way,
Okay.
for each one, it would call a lambda that was generated on the fly.
So you were doing it using some kind of key to say, okay. So key lookup for code to run. That's kind of reflection. But that's actually very useful. So far we have two things here. Directly adding a listener that calls an abstract method that we can implement. Very useful there. Setting up a map of here's the code that I want to run for certain keys. When the button is pressed, trigger the lookup and the run of that code. I've done both of these. What else can we do?
Kind of boring if you have like built-in actions that you just associate with that button.
Okay, built-in actions. So this is where we start getting into tweaking our language, right? So if our language has certain actions you can do on the button, you're limiting yourself to what you can do, but you now have the power to generate something for that, right? You can do something specific for a button. And as you start expanding that, to get more and more detailed actions, what happens to your language? Yeah, your language gets nasty. You start having to implement more and more real language features. And this is where it actually becomes useful to leverage something like XBase, which is where we can just say, hey, XBase already defined, and it's a good chunk of what extend is. It already defined all these features. You know, it has its lambdas, it has code, whatever, you know, ifs, loops, whatever. And I can just suck that in and just say call X expression or call X block. And instead of me having to define all that, it defines it for me. And if I'm targeting a language that XSpace targets, it can just generate the code for me automatically. So you can get some pretty powerful support out of that. But it's really increasing your complexity, right? The language gets more and more complex. So you either have to specify something very custom yourself or leverage the very custom stuff that somebody else has done. This is why they did XSpace, by the way, was for this specific case where they can say, in my DSL, I can go ahead and put a little chunk of code. I can do whatever I want it to do, as opposed to having to use some kind of an abstraction there. Okay. Now we can also go a step. Instead of having that abstraction, we can kind of squish the abstraction a little bit more and take advantage of conventions. We can say, if you have a button called foo, I'm going to assume that your subclass is going to implement a method called onFooPressed. And so instead of having a separate interface in the middle for it, we say, I mean, basically it's an abstract method it defines in the superclass that you have to implement, instead of having an extra step in there of what the listener is. So you can use some conventioning for that. But things can get pretty gross that way. What might be another way to hook up to that button? I apologize on the video. You're probably going to hear crackling of my water bottle there.
To maybe extend that class, like if you made these buttons protected members or something, you could extend it and let the user handle what they want to do.
So you're saying if we make these buttons be protected members, that gives us access, basically a handle to the button that we can hook stuff onto. So we can say, hey, foo button, add action listener, do whatever I want to. That's the next step here. But you have to be really careful about this. When can you access those members? After they've been created, which, depending on how you set up your user interface, can be tricky to figure out where to put that code. I mean, Android has done a nice job of having these lifecycle methods so that at certain points you know certain things have taken effect. And you can assume things are ready by a certain point, for the most part. There's a few spots where it's a little bit but we have a little bit of an issue here saying, how do I know it's actually been initialized? And this is something where I'm going to want you guys to do something interesting here. Let's say that in my code, I'm going to have button, add button. How, in my subclass, can I, from any method inside here, make sure that that add button has a valid value?
You either create it in the superclass constructor or you initialize it right there.
So we could create it in the superclass constructor. it's
constructor calls methods that you can override.
yeah, that's in general. You really don't want to have constructors call methods you can override. That gets into all sorts of issues. I mean, it's something that yeah, you end up wanting to have these common init methods and things like that. But if you have like a superclass that calls a protected init method, and then the subclass overrides the init method, the subclass generally makes the assumption that the superclass is completely initialized. But if your superclass constructor calls that init method, it's actually calling code in the subclass before it's finished whatever's after that init method call. And that's something that I did a long time ago. I remember spending about 2 days banging my head on the desk because I had overridden a method that was using a constructor in the superclass, and for some reason the data just wasn't there. I'm like, I'm setting this data is being set. Well, the problem was I was setting variables in the subclass that ended up being initialized after the constructor was actually done, which is what it should do. Because when you have the superclass constructor called, when your constructor is called, let's say I have class A and then class B down here. When class B's constructor is called, actually let me give some data inside here. So this is in B. I have variable X. And in class A, I have variable Y. So if I said something like X equals null, and then inside here I have an init method that says X equals hello, and then up here in A, I call init, and I'm subclassing it. Let's think about what happens for a minute here. I create a new instance of B. It goes up, the first thing it does, and tries to initialize its superclass. So the first thing that happens in initializing the superclass is it's going to initialize the field, so the field initializers are run, and then it runs the body of that superclass constructor. Then it's going to drop down to the subclass, run the field initializers, and then run the body of our constructor. So taking a look at this, your gut might tell you, I'm calling the initializer, the value of X should be hello. Unfortunately, the value of X at the end of this is null. Because what ended up happening is I call my superclass, he initializes his variables up there, runs the body of the constructor, which calls init, setting X to hello. Then it drops down to the subclass, runs the field initializers again, which explicitly set it to null, and then run the body of my method, which I'm not calling init because, hey, why should I? The superclass called init for me. I end up with a null. This is one of the few spots where explicitly initializing a variable versus using the implicit initialization of the variables makes a big difference. Okay, make some sense? I can show you more details in that example later if that comes an issue, but this is almost identical to what I screwed up. This was back along the, this is what, 97, I think? 96 or 97 when I hit this type of issue. And I was just learning Java at this point, and this really screwed me over. It was around the same time that the Gang of Four book came out for design patterns, and my nose was hitting the page every time I was trying to read the visitor pattern. So that's a bit of a problem there. We have to be really careful about constructors. Is there any other way this guy can make sure that whenever he accesses add button, it's going to have a valid value?
That's something where like the first time you reference it, it creates it. The second time.
You could have something where the first time you reference it, it creates it, and subsequent times it returns it. So we have a getter method that says, so if I have get add button, and if I make this guy private, right, and get add button says if add button is null, add button equals blah, 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 we're going to initialize it, and then return add button. Something like that, right? What's that pattern called?
It's
lazy instantiation. So what we're going to do is we're not going to bother creating it until we're asked for it. So if nobody ever calls get add button, guess what? We never create the instance of it. That's the lazy part of it. And sometimes that's really useful because maybe it's really expensive to create this thing and maybe you don't always need to create it. But now, no matter where we call this thing, we're guaranteed that that's going to have a valid value, right? Now think about creating your GUI code doing this. If I have an add button that's inside of a grid layout, and I create a get grid1 method, who inside there he says if grid1 is null, then grid1 equals new grid layout, well, new panel with a grid layout. And then grid1 dot add, to put that add button in, what's going to be the parameter passed to get one grid1 dot add? Get add button. Interesting, huh? So now no matter where you jump in that hierarchy, as soon as you ask for something, it creates it. Now this works with Java because we don't have to have superclass, the containing parent objects for the GUI exist before we create the children. Some user interfaces like SWT, you have to have a parent and then pass that parent to the constructor of the subclass. So this wouldn't work for that. But this is actually, using lazy instantiation this way is actually what Visual Age for Java used to do when it generated its code, which is something I really liked about the way it generated code. And you could actually, there was a couple options for generating code. This one, which some people looked at it and said, I don't get it, versus here's a blob. Oh, I get that. I mean, this I think is really elegant because it really shows you the structure of your user interface. At any given point, you could take a look at the getter method and see, what do I contain? It was all very self-contained.
It would add a pretty big amount of code bloat, right?
Some code bloat. Not a huge amount. I mean, the big difference is that you really have these if statements in there. But the huge advantage here is now, in that subclass, I can call getGrid1 at any point. Maybe the frame hasn't even been initialized. But I call getGrid1, it creates the grid, creates the add button, and I can call getAddButton and add something to it. And then maybe later, somebody calls getFrame dot set visible true. And then the getFrame creates the frame, fills in the other details that may or may not have already been created, and then shows it. Pretty nifty. And now I have access to any of this stuff that's in my generated code, no matter what the timing is.
So that access anywhere thing, I'm not seeing how doing the lazy instantiation is buying you anything over putting that all in a constructor, making them private. You can't access it until the superclass constructor's done. What do you like, right?
So the question here is, why not just go ahead and put everything in the constructor to start with?
Well, not I see why. I mean, I get your like organizational reason, but the like data protection reason, or the not data protection, but I think you understand what I'm saying?
Yeah, I know what you're saying. So it's like
What is that buying?
So the question is, what is this buying us? The first thing that this buys us is that maybe the GUI might have some conditional logic in it. So maybe the creation of the GUI is somewhat conditional, which could be driven by the subclass. So maybe I can't assume in the superclass construction that I can actually set up the GUI. You know, maybe something drives it, like a data input coming in. That's one approach there. Another thing is that maybe we can't create it up front for some reason. Maybe we don't have enough data to fill it in and say, create everything up front first, and then have it accessible. So it gives you some flexibility there, where you can basically build this at any point you want to. That's the kind of main thing going on there.
So then the getters
Not if you make them final. So if you make them final, then that's something here that'd be really good idea to make these guys final. Otherwise, yeah, you could override them, and then that could be interesting to say the least. Unless that's part of what you want to have be customizable. Maybe you have this general GUI that you're creating, general GUI, and the general GUI is going to be tweaked for several uses. I mean, think about what we have here so far. We can create a GUI and then have several subclasses of that same GUI that just plug in different things to do with those buttons. Or maybe we do override some of these to make some stuff conditional in the GUI. Maybe we're saying, hey, I just want to tweak this one part of the GUI. This little sub panel has OK and cancel. Maybe I want to change it so instead of OK and cancel, it just has OK in it. That could be a valid thing to do. And by overriding that method, that could do it for you. I mean, I'm a little less inclined to like having these things be overridden because I think that kind of can really screw with somebody's head reading this code, especially when it's structured like this. But when I saw them generate code like this in Visual Basic for Java, it's like I really thought it was very elegant. The thing that I hate about most generated code is this huge blob, which if granted, if you're starting with the DSL, you shouldn't care about the generated code all that much. But it's seeing this big blob of things and trying to debug it is kind of painful. This, you end up having to step through a lot of methods while it's creating it, but you can kind of see how it's being pieced together. It gives you kind of a nice recursive descent, going down to those leaves, creating the things, and then kind of percolating up as it creates the surrounding components for them. So this is what I want you to do for your assignment. And it shouldn't be a hard thing to add in there. I think I'm going to go ahead and give you 2 weeks on it. You probably really don't need 2 weeks on it. But I'll go ahead and make your last assignment be this guy for 2 weeks. And what I want you to be able to do is create a GUI, set up some subclasses that are going to tweak what the buttons do.
And that can be user-generated.
Yep. So this stuff over here, this guy, the subclass, that's code that you handwrite.
Do you want us like how Eclipse generates the wrapper or like the thing that extends the abstract side? Like, do you want us to generate just that or just not generate anything other than the core code?
I'm not quite following.
So if you go back to your Eclipse project,
Sure.
You're referring to elements?
no, well, it was that the abstract foo1 do runtime module.java?
Oh, this guy, yeah.
Right, so that's actually generated, but that can be changed by the user. Right.
Yeah, this one here. So this level here, this is the user generated class. The super class is the one that's actually the code generated one.
So you want us to kind of do something like that.
Yep.
We're doing an XX.
Yes. So you're just going to take what you had for the last assignment. So sorry, those of you who were kind of squishy on Xtext. Like I said, it's the choose your way to die by your favorite nightmare, that type of thing. But it's generating code this way. It shouldn't be a lot different from what you've done. It's just going to be structuring the code a little differently. And the main thing that I wanted to get across here is this idea of how we can interact with user-generated code. And so this GUI, what I want you to have this GUI do is set it up so that when you press a button, it goes and gets some data out of some fields and does something with it. So maybe you're just printing it out. Maybe you get some data from one field, put it into another field. Try out some different combinations like that. You should be able to get at any part of your GUI using this approach. And it's completely up to the user to decide what they want it to do. And ideally, define a user interface and have a couple different ways of overriding it. So you can see that, hey, I have my structure completely independent from how it actually runs. And there's plenty of cases where you're going to have a common structure for things, but you want it to behave differently. And this gives you that nice abstraction to make things behave a little differently. Let's see. Yeah, I did cover that. Good. Yes.
So the way, like the thing we're going to be running in the child eclipse is the hand-rolled thing each time?
Yes.
Okay.
Yeah, so the one that you're actually going to say run will be that subclass.
So the main will live there.
Yeah, the main will be in your subclass. And this is one approach you can take to access the data, and it gives you a lot of flexibility because now we don't have to have extra interfaces to implement. Because think about this for a second. Let me go back over to this picture here.
So then we have to make the method static. Like we're going to run from the main.
Well, in the main, what you're going to do is you're going to say get frame to create the instance of the frame, and then .show.
Right. It doesn't.
That's going to be it, yeah.
And that'll be it. Well, you'll create an instance of yourself in your frame. So if I had so let's say here's my DSL. It's going to generate my base.
Then you're going to extend your base.
I'm going to extend the base with my sub. I'm going to define a main that's going to say new sub is S. And then I can say s.getFrame .set visible true, something like that.
So what's the point of extending it if you're creating it in your main? You can extend it.
Well, it's when inside here, this is where you can actually extend to change some functions if you wanted to. So you can create this new sub. So you create the instance of sub, and then inside here you'd say s.getButtonX.addActionListener, and then say what you want to have it do there. If you have any questions on like things you can call on things, if you're not that comfortable with Swing, are you guys all really comfortable with Swing yet? I mean, you've done a little bit of it here and there, but adding the action listeners, it shouldn't be too bad. But if you have questions on specifics, let me know. But so the idea is you'll create the new sub, call whatever you want to do to set the buttons up, and then say the set visible.
Do we want to start with, so we want to have one DSL input and then like multiple subclasses that we're running?
Yeah, I would say, create like 2 GUIs to start with. So 2 DSLs, and then for each of those have 2 subs, just to kind of tweak it. And try to do something interesting, non-trivial. Basically, I'm thinking set up some buttons to pull data from one field, put it in another field, or maybe pull data from 2 fields, concatenate them, and put them in a 3rd field. Things like that. And maybe make the action a little different for each of your subclasses there. Yeah, the goal here is really just to kind of get you to have some feeling of getting that little separation and getting more toward a real application that actually does something. I mean, these don't do a whole lot, but it really starts to give you the flavor of how we can set these things up and take advantage of separating your generated code from your actual implementation inside there. Okay. And when we take a look at, let's see if I can figure out which one this was. Yeah, using this kind of approach where we're accessing the individual parts of the UE and attaching, this reduces the amount of callbacks we'd need to define. Because otherwise we would need to have something, what do I want? What action do I want to do? So they can set up action. What text do I want to put on it? Set up a callback for it. This way we have more flexibility to just say, go get it, and then I'll deal with it. Yeah.
Do we still need to have the validation in this assignment, or can we?
Yeah, just keep it the same way that you had it before.
So we're going to copy paste and then just modify it to match this project.
Yep. Yeah, you start with your previous project. And I would not be averse to you having the project have the same name. So if you want to just make a copy, make a zip of it and store it somewhere else, you can still have it be labeled, was it HW5 was the last one? So rather than having to create a new one and copy everything in there, you can just start with that as a base, and that would be fine. When you submit it, make it HW6.zip, even though the project still says HW5. But that way, it's like, you don't have to worry about renaming and all that crap. I mean, it's more noise. So you're going to take that thing and then extend it, adding in this new way of generating code. So, and it shouldn't be a huge change. I'm hoping. As he says with his evil little laugh there.
It is doing all the
Yeah.
until changing all the code generation, which was the worst.
It's not going to be all of it.
Right, so now we know where to go explicitly change it.
Right. Yeah.
It should be a little bit, it should be a little bit easier to modify.
Mhm.
Like the base stuff.
Yeah, knock on wood, that type of thing there.
As long as you didn't code it properly.
I mean, as you know, the thing is that the way these methods are written actually lends itself to recursive generation very nicely. So just be aware that what you're going to really need to do is, as you're recursing down to do your generation, make sure you fully generate the called methods before you generate the method you're working on. So don't say, hey, jump into generate this grid layout method, start generating code, and then call generate for the other methods, because then you'll get methods nested inside methods, which here it won't work. Now in Kotlin you can have local functions, which is actually kind of cool. It's, you know, it wouldn't help you here because you want them to be public functions so you can call them. But sometimes, you know, you might want to have, you know how a lot of times you'll have a method you call and then it's going to call a recursive function with a initial parameter? That's a perfect example of when you can use a local function where you just have that outer one and then the inner one is completely hidden from anybody else. And it's, you know, it's a real common use case for something like that. But this is what I want you to do is try out this kind of approach here. It'll give you some ideas on how you can do code generation. I mean, if I wanted you to do a big project, I'd have you do all these different kinds of code generation, but you know, or different types of abstraction. This is one of the more useful kinds of abstraction. I would very much avoid this. This is very commonly known as an anti-pattern now. This is what's called protected regions. And this is actually a really good example of, at one point, this was a pattern. I mean, this was the way people approached doing code generation. And this is something that in what GUI builder was it that did this?
Eclipses did like 12 years ago.
Oh yeah, when the early one the early GUI builder for Eclipse.
Maybe NetBeans? Maybe it was NetBeans.
NetBeans did as well, yes. Yeah, NetBeans was just, yeah, and this is awful. You really don't want to do this. Using just a little bit more abstraction, you can completely get out of this. And when you think about it, really, each of these begin-end blocks, just replace it with a call. That's really all it is. And it fixes it completely. You no longer have this issue. And this is just a nasty issue. But, I mean, this was, you know, the base way people thought about generating code. And when I started writing my GUI builder, I was basing it off of the Visual Age approach, where it had those nested Git methods. I just, you know, being one guy working on the GUI builder versus they had a team working on the other one, you know, it's just, there was no way I could keep up with it. But it was an interesting exercise to try out. It taught me a lot about code generation. Yeah.
Would we have to, I think we would have to modify our DSL, our language to incorporate names for the buttons as well. Because if we're going to be doing things like get,
Yes.
we'd have to
Yes. Yeah, that's a good point. So you're going to need to, for the names in the text fields already had names on them, right? Because those are being used as variable names. But yeah,
Names, sort of.
yeah, they're variable names. So you can still keep using those for the buttons, or for the text fields. For the buttons, yeah, you're going to need to add a name. That's a good point.
You were thinking of labels too, if you wanted to change those.
Oh yeah, we had labels. Yeah, do the same thing for labels. So everybody should have some kind of an ID on them, so that you can have those generated. Get something.
Everything, right? You want to be able to reference all those components.
Oh, that's true. Yeah.
It's literally every component.
Don't worry about it for the layouts. Just, you know, you can generate a name, so like, you know, get grid 1, get grid 2, get grid 3. That'll be fine for those. But for your label, your text fields, and your buttons, they should have IDs on them.
Do we have to generate available, like, visible getters for the layouts if we're not really
Yeah,
select them?
just go ahead and do that. I mean, it's just easier to keep it the same across the board. So they'll just be exposed getters. So if somebody wanted to, they could just go in and say, hey, give me this layout, and maybe they wanted to put a border on it. You know, if you're using swing, you could say set border. I want to put a box around this one.
Just have to guess which one's the layout 7.
Yeah. It's kind of, screw it. Put a name on everything. Thanks for talking me into that. I mean, that's actually,
One is not
it's really nothing. Yeah. I mean, it's just an extra thing in your grammar. But that would probably be the most common thing somebody would do is stick a border around part of the GUI. Other than that, you know, and feel free to do that. If you haven't done a border in Swing, no, don't flash, please. For God's sake, no. In Swing, if you haven't done borders, God, can I even remember how this looked? You can say whatever the component is.
Create something where
Okay, so you guys have done this.
Basically the same in all the
Yeah. Thank you, King of Siam. But yeah, something like that. Then, you know, if you can read that, good luck. But it sounded like you all have. It sounded like you guys have done it before, where you can just say set border factory dot create whatever. You know, create line border, create raised border. I don't think they have any normal animated boulders, but you could create a thread that just changes it. Give me epilepsy.
turn it on and
turn
on.
on and off. Turn on flash.
Now you had with the buttons, you had one that was like a really long button to make the space take up or something like that, as opposed to just setting it.
At some point, one of the assignments we had to pack the thing.
Yeah,
That was part of the.
and it's like your text fields go, which is kind of ridiculous. Yeah, I mean the alternative to that would be to set a preferred size on the text fields. That basically you'd have a subclass of it override set preferred size or override get preferred size, so that it returns a here's my comfortable size.
I just hard coded a
Starting to mess with sizes.
Yeah, exactly. I mean it's
The text field will be size 25. That made everything different. But you're right.
And that
Otherwise,
works.
It's like,
I was just like,
yeah.
just gonna add some text.
And then every time we test, we have to expand the window. It's like, oh, it's just, I usually, instead of packing, I usually just do a fixed size. I mean, it's just simpler that way. Okay, so let's see. Was there anything else in here? Merging. What is that guy? Oh, embedded language. See, I can't even read my own little chicken scratchings. So the other one that I mentioned. Somewhere. Well, I have no idea where I put it. But the other idea here is with your DSL, you have an embedded language, like using XBase or your own little expression language that you want to create for something like that. And just as a note on this, try to keep your DSL as simple as possible. I mean, if you can keep it to as much as you can, just a data model, a very simple data model, reduce the amount of expressions. So like an ideal thing here, the validation language would be gone. We wouldn't need to have all that extra logic, because now we can just say, plug it in, and then have Java code do it. Be much simpler, right? I don't want you guys to have to undo what you already did, so just go ahead and keep it in. But that would be one way that we're actually simplifying things by using this approach, instead of having to have this special language for validation. But I definitely wanted to have you guys do the validation so you can kind of get a feel for here's how I deal with expressions, especially. I mean, because that's something, if you're ever doing any type of language design, you're going to have to deal with expressions. And after you've done them a few times, they're really not that bad. But the first few times, yeah, they can be a joy. And especially if you're getting to a real language that you're doing a compiler for, then they can be real fun. But I love this stuff. What can I say? I'm a compiler guy. I enjoy it. Hopefully you guys have gotten a little bit more comfortable with these things. And my hope is after this class that these types of things are tools that you can actually put in your toolbox, and if you need them, use them. And hopefully find them useful someday. So, okay. So I think that is all I wanted to cover today. Next week, I'm going to try to do some visualizations. I was thinking of having you guys do an Eclipse plugin to help visualize your GUI. I decided this was going to be a more useful thing, but what I wanted to do was use Zest in Eclipse, which is a really simple framework where you can define a graph based on some other data. And so basically what you do is say when you click in the editor with your DSL, it loads that model up, and then you could display a graph to represent it. So you could actually have frame and then underneath it the different components, and it would show you a tree. And you can do it in almost no code at all. So I'm going to show you how to do something like that next week. I was thinking having you guys do that. When I was running through the examples, I was having a bear of a time with it because I haven't done Eclipse plugins in a little while, other than Xtext. But it's like I used to, for the design pattern class, always have everybody do everything with Eclipse plugins. And it's been over 10 years since I've done that, and things have changed in Eclipse for the good. But it's changed quite a bit.
Is Z a Z or like an X or something?
Z, and it's built on top of Gef, the graphical editor framework. Gef is a fantastic framework, but it is a lot of code to write. I mean, it's very tedious. So they built stuff on top of it, like GMF, graphical modeling framework. Sirius, which I started to show you, that's real new still, so it's flaky. But Sirius, they try to set it up so it's more of you're declaring what you want, and then it generates all sorts of crap behind the scenes. With Gef, you got to write a lot of code. And GMF is kind of a mid-ground where you're writing specifications and it generates all the Gef code for you. So I think Sirius is more driven at runtime. I think there's some code generation, but most of it is runtime. So there's different layers of doing things, but Gef's a fantastic framework. And I started writing, actually the GUI builder that I was writing, I was using Gef. And it was looking pretty nice. I mean, it's you basically say here's something and you have containers inside it, but it was a buttload of code to set everything up. But it was really well designed. It's just a buttload of code. So, okay, any questions on anything? Thank you again for switching the time here. I really appreciate that. And our end time is only half an hour from where we used to be, which is cool. Okay, so I will see you guys next week. I will try to post an assignment description a little later if I don't pass out.